Hello everyone and welcome back to a new video. So in this video what we are going to do is that we are going to discuss about the different number system conversion as well as different type of operations on different type of numbers, mainly on binary numbers, the operations on binary numbers. So as you can see, these things we are going to discuss: decimal to other conversion, after that other to decimal conversion, okay, and after that complement and related sums, okay, complement for unsigned and signed integers, signed numbers actually, uh, and after that some basic examples or some example, okay, to understand about the process. So that will be our approach. Let me see if my mic is working fine. So I think it's working fine now. Let's start with the first thing, the basic thing which you need to understand before jumping to that thing, okay. Okay, so now let's at first discuss about the base and radix. So the base or radix of a number system determines the number of distinct digits used to represent values. Okay, like for at first let me read it out, then I will give you an example, or I will explain it to you. So after that, so for an example, for in case of decimal number, the base is 10. So the thing is that in case of decimal number, if we are writing some digit, okay, so there the numbers can be uh, 0 1 2 3 4 5 6 7 8 and 9. We cannot consider 10 as decimal number, okay. So its base is 10. After that, binary number, in case of binary number the base is 2. It means we can only consider the numbers to construct any number. The numbers which we can consider is 0 and 1, okay. Using 0 and 1 we can form a number. That is the thing. After that, in case of octal, uh, whose base is 8, oct means 8, so that's why the base is 8. We simply use like it uses digits starting from 0 to 7 to represent that type of number. And in case of hexadecimal, the base is 16, so that's why it actually use 0 to 15. But in case of this type of representation, starting from, like normally we represent 0 to 9 like a number, okay, 0 1 2 3 4 5 6 7 8 9. But whenever 10 comes, we represent it with a letter, capital letter A. Likewise 11 as B, okay. And in that way till F means 15, 15 representing F. So in that way you can calculate. So if I give you an example of hexadecimal number, in that case you have to consider like that, okay. So let's say if I here give you an example of different type of numbers, so let me go to Google and it will be more clear to you. So let me at first go to Chrome and example of each type of number, okay. Let's see if it's giving. If it not giving, then I will show you each type of number. Then let me mention uh, just a second, let me check if my, yeah, it's running actually. So binary, okay, decimal, hexa and oct, okay. So different type of numbers are actually there. So as an example, here you can see this number, this number's base is what, 2. So it's a decimal number, sorry, it's a binary number. As you can see in our notes, the base is 2 means it's a binary number. And we can represent this type of number only using this 0 and 1. So that's why you can see this number is represented using 0 and 1. Similarly, base 10 means decimal number. So in case of decimal number, base is 10 means we can put here 3 starting from 0 to 9. Okay, these digits we can put here to represent a decimal type of number. So in that case the example is like 348. So everything is within the range, and after that here you can see this is hexadecimal because the base is 16. So 1 we are considering as 1, 5 we are considering as 5. C means what? A means 10, B means 11, C means 12. So 1 5, then the number was 12 and we have represented it using C. So that is a hexadecimal number representation. After that octal. So in case of octal representation, uh, it's starting from 0 and we can take the digits up to 7. Okay, so in this case 534, which is in within the range from 0 to 7, so that's why it's a octal number and base is 8, as you can see. So these are different type of representation. Now so I think it's all clear to you. This question also can be asked that what is base or radix. So base or radix of a number system determines the number of distinct digits used to represent values. So that is the thing. After that, let's see the simple conversion. Okay, there is no fractional number. We are just converting a simple number, normal integer type of number. It's not a fractional number. Fractional number means, as an example, something point something. Let's say if they are inside this, if there was written the 255.34, so this would be a fractional number, but in our case this is an integer number. So at first let's see the integer conversion, and after that we'll be focusing on the fractional conversion. So I have a trick for you here, that number system conversion. So let's say there is a decimal number given. Okay, so as you can see 255 is the decimal number in our case, and it's if they told you that it's a decimal number means its base will be 10. Okay, now there is this convention 1 2 4 8 16 32 64 means 2 to the power 0, 2 to the power 1, 2 to the power 3 4, likewise it will go up to like many times. Okay, but let's say in case of this, maybe it's up to 2 to the power 0 1 2 3 4 5 6 7, so it's up to 2 to the power 7. The calculated value is 128. Okay, for 2 to the power 6 the calculated value is 64. So likewise 2 to the power 0 the calculated value is 1. Now we are converting decimal to binary. Okay, let's say there is a question that we have to convert this number to a octal number. So how we will do it? So at first this is the decimal number. After that the binary number, we will convert it to binary number. How we will convert? See the number 255, and in this list just ignore this list. Can you see the pointer, my pointer? So just ignore this for now. See the black portion. Okay, here what is the largest element which is near to 255? Okay, which is 128, because after that if we do 2 to the power 8 the value will become 256. Okay, I think it will be 256 because multiplied by 2, so 8 to the, okay, so it will be 256. And after that if we try to write 1 under that, why we are writing 1 actually, let me see, tell you. There after this number there will be 2 to the power 8 means 256, and this number is lesser than 256, so we cannot take that 256 here. 255 is lesser than that, so just put 1 under the number just lower than that number. Okay, and which is closer to the decimal number which we have to convert. So in our case we have taken 1 under this because we are converting, like we are considering 128 in this case. What is the remaining value? Now minus 255, like minus 128 from 255, remaining is, there will be something remaining. Okay, and you have to calculate this thing, which digits I can take combinedly to get that number, which digits I can take combinedly and add them and to get that number. So that will be the process. In our case coincidentally we have to take each digit after 256. There would be 256, but I have not written here. But the number is 255. Okay, so that's why. So coincidentally, if I calculate, under every number I have to write 1. If any number I have to reject in any case, then I have to write just 0 under that. Okay, so that is the thing. After that, which number we are getting, like 1 1 1, in case of us we are getting 1 of uh, like 1 in every, under every number. Okay, so that's why our binary representation of this 255 will be that number, that 1 or 0 combination. Coincidentally, in our case there is no 0, but maybe there will be 0 in case of any number. So that is the thing. But this is the converted binary number. Now from binary number we want to convert it to octal. So in case of octal, the base is 8, means what? Base is 8 means 2 to the power 3. Okay, 2 to the power 3 is 8, 2 to the 4, and if we multiply another 2, it will become 8. So the power of, like, if we convert this 8 to the base 2, then it will be 2 to the power 3. It means, let's take the 3. So you have to write that 3, draw that 3 boxes. Okay, 3 boxes in a row, and as you can see, 1 2 3 4 5 6 7 8, 8 digits are there in case of binary number. So in a single row we can put 3 boxes. So how many boxes we need? Okay, how many boxes actually we need? We have to start adding boxes starting from here. Okay, starting from this side, from right side. So this is the first box, second box, third box, fourth, fifth, sixth, and in the next row 7 8. Okay, 7 8. So that is the thing. Now we can take also 9 and put uh, in uh, in that case 0. Okay, so we have to put 0. We have to actually complete these boxes. Now just calculate the value under which 1 is there. So in case of first row, under every digit there is 1. So this 1 2 4 is like that, 1 2 4. Okay, so wherever whatever is needed we have put in there. So in case of under every digit there is 1, so just add it, 4 plus 2 plus 1, so 7. In second row there is also under every digit 1. 1 means it's true, so let's take it and add it to the sum. So 4 plus 2 plus 1, 7 again. In case of third row, there is 1 under 2 and under 1. Okay, under 4 there is 0, so we will not consider 4 here. We will just consider 2 and 1, because 1 is present in that boxes. So just add 2 and 1, so the number is 3. This is the converted octal number of that decimal number, or of that binary number. If some number is given in binary format, so you can definitely convert it now in the octal format. If some number is given in decimal format, so at first you can convert it to binary, then from binary you can convert it to octal. So that will be the process. Just revise this thing, you can do it. Okay, so that was the thing. You can see here I have written the result as 377 and base of 8. Okay, in case of hexadecimal, simple. What is the base? 16. So we have to take 4 boxes. 2 to the power 4 equals to 16. So we have to take 4 boxes. So simply I have increased the digit, another digit here, means 2 to the power 0 means 1. 2 to the power 2 means, sorry, 2 to the power 1 means 2. 2 to the power 3, 2 to the power 4 means, like 2 to the power 3 means 8. 2 to the power 2 means 4. 2 to the power 1 means 2, and 2 to the power 0 means 1. So we have, as we have to take 4 boxes, so I have taken this number still 8. So so how we are calculating? We are just starting from this portion and putting it one by one. So uh, in place of, in case of binary, there is 1 here, so put 1. Then in place of 2 there is 1, so put 1 here. 4 there is also 1, put here. 8 there is also 1, put here. Okay, that is the thing. After that, this is 8. After that, 16. As we are shifting that 4 container below that, okay, in that case, in hexadecimal case. So just shift that part, that 4 container part below that, means 16 is coming under the 1, 32's number means 1 or 0 whatever is coming under the 2, 64's is coming under the 1, and 128 is coming under the 1, nothing is remaining. Okay, in that case, in octal case, as we were doing like 3 boxes, so it was like 1 2 4 in a single row, then 8 16 32 in a single row, and starting from this side to this side, just remember this, not this side to this side. So it's going from right side to the left side. So 1 1 1, and after that last remaining 1 1, but lastly there is no number, means it's 0, so it is 0. Okay, so likewise, let's come to the hexadecimal format. So in this case also we have done the same process, and fortunately it's completed. And now just add the digits for each row. So 1 plus 2 plus 4 plus 8 in first row, or and also in the second row. So the number is 15, means hexadecimal number will be 15 15 to the base 16. Okay, now we cannot write directly the 15. What is the representation of 15? A means 10, B means 11, C means 12, and D means 13, E means 14, and F means 15. So we are representing as FF, double F. Okay. So that is the thing that we are converting it. Similarly, if you reverse it, let's say there is 15 inside you and it's given, they have given in that format. Okay. FF16. So at first what you will do? At first you will make that box. Okay. Uh, as you know, in case of given hexadecimal format, the base is 16, so I have to make 4 boxes. So at first, like, make that 4 boxes. After that, take the first digit, okay, and represent it in the 4 uh, like 4 placed format. Okay, like you have to use the 4-bit format. So like in case of F, it means 15, so you have to uh, convert it to the binary format. So convert 15 to the binary format. If you convert, you will get this 1111. Okay, just put it inside that first box, like starting from 1 2 3 4. Okay, likewise for next F there will be 15, so put it like that. So that is the thing. Likewise, we have already got that thing. So now just shift it to that format. Okay, just this is your HW, just reverse engineering it and you can do it. So it's very simple. If you have any question or any query, I will do so many questions later, practice questions based on that later. This is, you can take it as revision or like small understanding purpose. If you have understood, then it's very easy or very nice. You can definitely identify it by yourself how it's working. Just identify it. Okay, so that is the thing. Now let's come to the general purpose, or like general method. Okay, decimal to other conversion, fractional number. So at first let's convert from decimal to other. Here you can see decimal to binary fraction conversion. What is the base of decimal? 10. What is the base of binary? It's 2. Okay, so as an example, it's a fractional conversion. So I have taken a fractional number. As you can see, convert the decimal number, which is 12.06225 and to the base 10 into binary number. Okay, so what will be the solution? You have to divide that part aside, and you have to perform an operation on that part, like 112, like 12 part, which is in the left side of this point. Okay, and which is in the right side of this point, you have to perform another operation here. So that is the thing. Now if we take the part in the left side, which is 12, what you have to perform? So you have to divide it by the base to which you want to convert. Okay, like in case of ours, we want to convert it from decimal to binary, means what is the base of binary? 2. So we are dividing that left part by 2 till it becomes 0. So 2 6 are 12, so it's 0 and it's 0. After that 2 3s are 6, so the remainder is 1. In previous case the remainder was 0, so that's why I have written 0. After that 2 1s are 2, so remainder is 1, so that's why I have written 1. So like it's working like that. Okay, so like I think 0. So what is happening here? 2 6 are 12. Okay, it's 0. Like they have just written this 0 here on the upper part, you can write it in the lower part also. 3 2s are 6, so the remainder is 0. After that 2 1s are like 2, so the remainder will be 1, as you can see here 1. After that 2 zeros are 0, 2 zeros are 0, so like 1 minus 0 means 1, so remainder is 1. Ultimately there will be 0. So that just you are dividing it. Okay, so like now we will go from below to the top, and we can write it like that. As you can see, this is actually 0, the last digit is 0, so we need not to consider it. If there was a 1 0, like there was another 1, so then we had to consider it. But now we have no digit here left, so that's why we are just cancelling out this 0 and we are taking from 1 1 0 0. Okay, so 1 1 0 0. Now point, now what we will do with that part 0 6 2 5? So we have to multiply it with the base. Here we are dividing it, here we have to multiply it with the base till the right side part becomes 0. Let's see what is happening actually here. So at first we have multiplied the base number, which is 0.0625. So here it is written that 0.0625 multiplied by 2, which is 0.1250. So the remainder is 0 definitely. Like not the remainder, actually this part, like the after multiplication, the left part of that result, here it is 0 till now. Just follow my cursor. So here I have written 0. After next, in the next step, just take this number. Okay, actually we are taking the right part here. So right part is 0.1250. So 0.1250 multiplied by 2, which is 0.2500 again. So in that case also the left part is 0. Okay, there is no integer, so we have written 0. Similarly we are multiplying 0.2500 in the next step with the 2, so 0.500, and now it's also 0 because as you can see the right part is 0. After that 0.500 multiplied by 2, which is 1.000. Okay, and the left part is in that case 1, so we have written 1. After that if we try to like multiply 0.000, it's meaningless, because after that in every step it will just give us result like 0.000. So that is the thing. In that case, in multiplication case, we have to go from top to bottom and write it 0 0 0 0 1. Okay, so as you can see the result from here, we are getting 1 1 0 0. We are ignoring that 0, so 1 1 0 0, then point. Okay, then point, then starting from top to bottom 0 0 0, as you can see 0 0 0 1. So that is the converted number from decimal to binary. Similarly, this will be your HW. Here what I am doing, I am just explaining it in short, that here we have to convert from decimal to octal. Means what is the base? 8. Now we have to divide with 8 and multiply with 8 with the same approach. Okay, same approach. Here we are dividing it till the remainder becomes 0. So 828 is 225, so the remainder is like not 225, the remainder here will be 1. Okay, after that we are again dividing it by 8, so 8 3s are 20, like 24, so the remainder will be 4 in that case. After that 8 zeros are 0, because 3 is not actually divisible by 8, so zeros are 0, so 3 will be remainder, and now the number becomes 0. We cannot divide 0 by 8. Okay, it will be meaningless. So 3 is the last thing. So 3 4 1, we have written 3 4 1 here. Now the right part 0.225. So 0.225 we have like multiplied it with the base to which we are converting, which is 8 in our case, so 1.800. In that case we are taking this one which is in the left part, okay, aside, and after that we are multiplying that right part, means 0.800 with the base, means 8 again, till it becomes 0. So that is the thing. Or like we can do some steps and after that we can skip some steps. So now we have to do like 5 to 6 steps. Within that, if it comes as 0, then we need not to definitely we have to stop that, or else we can just skip the other steps after other multiplications after that. So as you can see here in the second, here we have multiplied it and the 6 is in the uh, left side, so we have taken this 6 from here. Likewise in the next step with 0.400 we have multiplied the base, and now in our case in the uh, left side of the point there is 3, so we have taken 3. In that way we have done till that, because the repetition is coming after that 0.800 which is also here. Just follow my cursor, okay. So that is the thing. So in that case, as I have mentioned before, you have to take from top to bottom. So as I have written here, after point 16 from top to bottom 16314, okay. So 16314, this comes from here from bottom to top 341 and point then 16. So that is the thing. In that way just try with the hexadecimal. In case of this we are taking the base as 16 and multiplying also with the 16. So that is the thing, okay. And don't forget to convert this, like as you can see here we have like taken, or we got the remainder as 14, so you have to convert it to that later format, okay, because it's a hexadecimal. So we have written it like that. We are like getting 14 and 1, so 14 we have converted to e, and we have written e1.39 from here. So that is the thing. Now other to decimal conversion, okay, fractional number. So at first see the fractional number. I will show you one, and you will try the other. So that will be a HW. Now let's see the conversion from octal to decimal. So we are going to convert from hexadecimal to decimal. Till now we have done the decimal to other conversion. Now we are converting others to decimal. So that is the thing. So at first let's see an example with the octal. Then others you can do it by yourself. So let's say this is a octal number, as you can see here 1725.43, and in the base there you can see 8, okay. Let me capitalize, like, oh, just a second, let me go to that page. Yeah, now it will be more clear. So let me take that laser pointer. Now you can see 1725.43 and in the base 8, okay, and we have to convert it to the base 10, means to the decimal actually. What we are doing here, we are taking each digit, okay, this is 5, this is 2, this is 7. So in case of right, like in case of left side, what we are doing, we are like multiplying that number, okay. Let's say in the first position or the first index in the left side of that point, there is the first digit is 5, so we are multiplying it 5 multiplied by 8 to the power 0. Why? Because the current base is 8, not the converted base. The current base is 8, so 8 to the power 0. Likewise we are adding like in the middle plus, after that the next digit 2, so 2 multiplied by 8 to the power 1, so power is actually increasing, okay. 7 multiplied by 8 to the power 1. From where this 8 is coming, this is the base of the current number, from where we have to convert to the decimal. Similarly it is going till that, okay. Whatever number will be there, you have to go till that. Now you have to calculate that separately and add them. So the 981 is the result of the uh, left side. Now go to the right side. Here we are multiplying with 8 to the power 0, 8 to the power 1, 8 to the power 2. Here what we have to do, we have to divide by 8 to the power 1, 8 to the power 2, 8 to the power 3, and we have to skip the 8 to the power 0 here, okay. We because 8 to the power 0 is cannot be negative, okay. So that is the thing, okay. So in the right side, as you can see we are doing, we are taking the digit and the first step, we are dividing it by 8, means 8 to the power minus 1 is actually representing we are dividing by 8 to the power 1 plus next digit 3, and we are multiplying by 8 to the power minus 2 means we are dividing by 8 to the power 2. Okay, so that is the thing. So this digit will come, just add it with the remaining one. Okay, so that is the thing, you can directly like write like that, it will be better, and then add everything once, and that will be your answer in decimal. Likewise, in case of like binary to, this is in case of binary to decimal. Okay, this is in case of octal to decimal, which we have recently done. This is in case of hexadecimal to decimal. Everything is similar, just we are multiplying and adding everyone together. Okay, so that is the thing, that will be your HW. As you can see here, from binary also I have used just the base. Okay, I am multiplying each digit with the base, and just remember, in the left side of the point it will start from the power 0, and in the right side of the point the power will start from -1, -2, -3, like that. Okay, means we are actually dividing by 2. Okay, so that is the thing. In case of hexadecimal to decimal, what is the base of hexadecimal? 16. So we have multiplied by 16. 16 to the power 0, 1, 2, 3 in the left side, and in the right side 16 to the power -1, 16 to the power -2, like that. So that is the thing. Here is the important point: in hexadecimal, A represented by 10, B represented by 11, C 12, likewise other things also till 15. Okay, means F. Okay, so till that we have completed this conversion part completely. If you watch this video, watch till that part and understand each and everything, practiced by yourself with different examples, search on Google and practice with that examples, no questions will be there which you will not be able to do. Okay, so that is the thing, just use that trick, that thing, and you are ready to go. Now the remaining part which is remaining to us is that complement and related sums. Okay, let's see, before that we have to understand the basic thing, some basic thing, that addition table. So let's see addition table in a within some minutes. What is actually, if there is a number 0 0, okay, we are actually doing the digital sum here. Okay, so actually 0 0, sum will be 0 and carry will be 0. In case of 0 1, just remember, sum will be 1, carry will be 0. You can remember like that, carry here, in place of sum there is carry, and in place of carry there is sum, then this digit will also be shuffled. Okay, how I am remembering? If you know the basic chart, let me show you. uh, Decimal, sorry, what is the thing, like binary to decimal chart. Let's see. Yeah, so this is the chart. If you know about this, let's see the chart at first. So 0 0 0 0, what is the decimal form? 0 0 0 0 1 means 1, representing 1. 2 is represented by 1 0. Okay, 3 is represented by 1 1. So till that fourth row, our work is till that, for performing the sum operation. Here, for remembering purpose, you can consider it like that: the right digit is for sum and the left digit is for carry. Let's match it with our existing sum table. So let's match it for 2. Okay, so 2 means 1 0. So if we are doing sum of 1 0, okay, if we are doing sum of 1 0, then it should return what, like let's see, let's go to that part. Okay, let's sum of it. 1 0, 1 0 plus 1 means 1. So 1 is representing what? 1 is representing, in the table, what it's representing? 1 is representing 0 1, and 0 will be carry, means the left side will be carry and right side will be sum. So in place of sum we will put 1, and in place of carry we will put 0. Let's see. In place of sum we have put an 1, and in place of carry 0. So I think you have got it. In next case 1 plus 0 means 1, so similar result will be there. 1, the sums, whatever the sum is here, we're representing it to the binary format. Okay, and in the binary format, we are taking the right part of that binary format. In case of 1, if I show you, the right part is 1, so we are taking the sum as this right part, and for the left part we are taking it as the carry. Okay, now let's take another example. This, okay, this 2 in the last case, 1 plus 1 is 2. So what is the binary format of 2? It's if we see 1 0, and as I have told you, here you can see 1 0. So 0 is representing, means right part is representing the sum and left part is representing the carry, means 1 is carry and 0 should be the sum. Let's see, yeah, 0 is the sum, 1 is the carry. So that is the thing. Okay, so that is the thing. In case of borrow, you can remember it like, I'm not explaining it too much. If you do it like that, you can get it. Okay, 1 minus 1 is 0, and 0 is represented by 0 0. So in right and left part there will be 0 0. So 0 minus 1 is also like, you can represent or remember it, like simply remember it, it's not needed. So let's see a simple addition of two numbers which is represented in decimal. So from decimal we have to at first convert it to the binary, and then we have to do the sum. Okay, so that is the procedure. Let me see how much long till now our video. Just a second. Okay, so it's about 36 minutes, so I think we can complete it in today's video. So as you can see, we can add 13 and 7. So at first, if this type of sums are given, at first you have to convert 13 to the decimal form, sorry, binary format. So what you can do it, as you can see, the format I have written 2 to the power 0 means 1 2 4 8. I have written this raw format 16. Okay, 16 is actually inside this box, so but the color is different although. So but that is the thing. Okay, after that I am trying to represent that 13. Okay, how I am representing, at first see the maximum number in that box. Okay, in that box, just focus here. Let me take that pen, like laser, just focus here. Okay, what is the maximum number, what is the like minimum number which is lesser than 13? Sorry, the maximum number lesser than 13 is 8. So under 8 just put 1. After that, what is how much is remaining? 4 5 5 is actually remaining after 8 to make 13. So we can take 4 from here. Now remaining is 1, so just skip 2, just put 0 under that and 1 under the 1. So if we now make the total of it, 1 plus 4 plus 8, it's now 13, as you can see. So in that way we can simply represent that 7. How we are representing 7? So as you can see, what is the largest minimum number, largest number which is lesser than 7? It's 4 in that box, because 8 is greater than 7. So under 4 just simply write 1. After that, how much is remaining? 3. So let's see, 2 and 1 is remaining. So inside 2, 2 is lesser than 3, so we can put another 1 here, and remaining is 1, so simply put 1 under here. So, okay, now wherever 1 is like written, just make the sum of that number. So 1 plus 2 plus 4, it's 7. Okay, so 13 7. Now how we are doing the sum? If you can remember, in our previous page there was a like table. Okay, if we now let's do it by that. Here you can see, just don't see this upper part, this part don't see. Okay, just see, let me like use the pen. Just don't see this part for now. Okay, just see this below part. Okay, now as you can see, we are adding 1 with 1, 1 with 1. Okay, So if we add 1 with 1, what is the sum normally? It's 2. And in case of 2, what I have told you, what will be carry, what will be sum. So if we represent 2 in the binary format, it's like uh, in the binary format it's 0 1. Okay, if I show you the table, as you can see 2 is represented actually 1 0, not 0 1, 1 0. Means the right side is actually representing the sum and left side is representing the carry. So after doing, we have to write the sum here. Okay, so just let me take that laser instead of that pen. So I have written sum as 0 here. Can you see here? I have written sum as 0 here. Here you can see it's more clear. And the carry I have taken in the next step. Carry is 1, so carry I have to take in the next step. Now just do sum of this 3 digit. 1 plus 0 plus 1 again 2 means sum will be 0 and carry will be 1. So carry will go to the next step. Now 3. Okay, this is 3. So what is the binary representation of 3? Because we sum this 1 plus 1 plus 1, it's becoming 3. The binary representation you can see is 1 1, means sum is 1, carry is also 1. So that is the thing. Okay, so I have written the sum here as 1 and I have put in the carry or taken the carry in the next step as 1 also. Now in that step I have added this 1 and 1 and it's 2. And if we see the binary representation of 2, it's 1 0, means 0 is the sum part, means right side is the sum part and left side is the carry part. So I will simply write the sum part here and I have to give that 1 in the next step. Next step I had to give, but there is not another like there is no calculation for now, so we can directly write it here, write the 1 here. Okay, so the in grand total it is 1 0 1 0 0. Now if I put that table, if I use that table 1 2 4 8 16, in case of this, as you can see here, this is the final result 1 0 1 0 0. And just for now cancel this out, like don't see these two things, just focus on this first row and this last row, means fourth row. As you can see under under which digits there is one, this there is here is the one, it's under 4. Okay, so take the 4. Now here is 0 and here is 1, it's under 16. So we have just got 16 plus 4 and the sum is 20. Now if you match it with the, like, we have done it using this decimal for binary format, but in reality also if you directly add them 13 plus 7, you can get the same result. Okay, 20. So that is the thing, in that way you can do the sum. Just practice with different things, like different numbers, you will get it definitely. Okay, so after that there is this complement thing, I will explain it to the next video, it will be better to understand. So that's for today. uh, Let me discard it. Okay, so that's for today. In next video I will be explaining to you with more examples and this complement type of things. Okay, so just check the notes in the with the link which is given below in the comment section. And don't forget to give a like to this video and subscribe the channel. If you have any problem in the understanding part, let me know in the comment section, I will explain it in more detail in other video if it's needed. uh, so that is the thing. So that's all for today. So yeah, in next video we will be discussing the next parts. Thank you for watching this video till the end.